Okay, done. Okay, so good morning, everyone. Thank you for joining us at the last session of the Open Access Week 2023. And I'm very happy to introduce Sarah Jones. That is our presenter for today. And Sarah Jones is an EOSC Engagement Manager at GÉANT, where she works with NRENs on supporting open science. She's an information professional with over a decade working in research data services in the higher education sector. At the Digital Curation Center, she led the DMP online service and worked on constantly and consulting and training. Sarah was a reporter on the European Commission Fair Data Expert Group, an independent expert on the EOS Executive Board, chairing the FAIR Working Group. She now sits on the EOS Association Board of Directors. So the stage is yours, Sarah.
Excellent. Thank you very much. Thank you to all of you for attending. What I've been asked to speak about today is just generally about sharing, managing and sharing data and kind of some lessons from the European context. So I'll pick up on things like EOSC and what's happening in different universities. For those who, you may have heard this announcement already, I've put together a Mentimeter to try and just understand what you know already and what the extent to which I should explain different concepts and go into different things. So if you can go to menti.com and enter this code 54436540, I've put it in the chat as well. We can just understand kind of what we want from the session and use that to direct the level we go into different things. So I will come out of the slides just now and go to the Menti. And just see if we've got any responses. If this doesn't work, we can just kind of talk as well, which is fine. But I'll go to present. So the first thing is really understanding who you are and what you want from the session. So I'd ask questions about, what your role is. It's nice to see we've got a mix here, actually. So researchers and also librarians. And I think, each stakeholder plays a really important role. Obviously, researchers, you're creating the data, you're having to manage it day to day. But in order to do that effectively, you need support from your institution, from national services like repositories, or from your community to understand what disciplinary metadata standards to follow. So it's nice to see we've got the mix, because I think each stakeholder plays an important part in managing data and open science. I don't know if anyone who said other wants to speak out about their role. I know people don't always like to speak openly, so don't worry if you don't want to. You can also put things in chat if you like. Okay. But yeah, nice kind of balanced mix. I'll come on to the second question, which is what you wanted to learn from the sessions, whatever you're here to teach me. Well, I'll kind of talk in a moment about what I'll cover, how libraries can help researchers with data management. I've got some content about things libraries in other countries have done, where to find open data. I haven't covered that specifically, but I can reflect on that. There's lots of repositories where you can search for open data, tips for research data management services, best practices and tools. So I think a lot of these things will be covered. But as we go through, if I'm not answering the questions, you have put them in the chat, or you can speak out as we go through. Understanding data management requirements. I think I don't know the context in Israel as well, but lots of funders or the European Commission have expectations that researchers make data open, and I can reflect on that. More about open data, how it works. I've got some content in the presentation to explain how to make your data open. So hopefully a lot of the things you're looking for here we'll cover in the session. But if I don't answer your questions, let me know as we go through, and we can pick up on that. So what I'm gonna cover today, kind of switching between the... Sorry, did you have a question?
לקחנו אותם כמה פעמים, והם כאילו היו בסדר, נכון? כל פעם אתה מצא...
שרית, can you...
Yeah, I will do it immediately, yeah.
Okay, so what I'm going to cover today, I've got a few sections in the talk. First off, I'll explain concepts. So I'll explain what research data management means, what FAIR means. I don't know if that's an acronym you've heard, and also open science. So I'll begin with a kind of overview, and then I'll pick up on what EOSC is. I don't know if you've heard of the European Open Science Cloud, but I'll explain that. And then at the end, I'll kind of do the kind of practical thing, what it means as a researcher to practice open science, and also what it means as an institution. How are different universities supporting researchers with open science? So that's the kind of overview of the talk. I did have a question just to start us off on the first section, so I'm going to come back to the Menti. I have a couple of questions here. The first one is about what you immediately think of when you hear the term open science, because open science is quite a broad-ranging thing. And I think the terms you've got here are exactly right. It's about open access to publications. It's about open data, about sharing data, obligation. I think that's also important because often there's policies that are requiring open science. Predatory publishers, that's also key. I think the open access movement is in some ways, you know, the publishers have their business models and that can be thwarting the openness. MOOCs, I don't know if everyone knows what a MOOC is, a massive open online course. So open science also covers open educational resources. Digital public diplomacy. I think the concepts behind open science are about, you know, the sharing and equity and diplomacy. So you're definitely all getting the right terms here. So thank you for that. And then my other question is whether you've heard of FAIR. Half of the room have, half haven't. I'll explain the concepts and let me know if you need more detail as we go through. And then the final one before we begin, what's involved in data management. So policies, yes, lots of policies on data management. It's about opening data. DMP, this is a data management plan. Lots of people will be asked to write a DMP for their research funder. Python, so yeah, the kind of the code people are using, the different tools they're using, the software, the servers to make sure we can store and share things. Efficiency. I think one of the drivers behind data management is making sure your content is well organized, that you can find it, you can share it with the right collaborators. So yeah, these are all the kind of key things in data management. So I think you've already actually got a very good understanding and grounding. And what I'll do is try and just help explain things more through the presentation. As I go through, if I speak too fast or if I use terms you don't understand, let me know. I can slow down and I can explain things as we go through. So as I mentioned, the first section I'll do is introducing the background concepts. So what is data management? What is FAIR? What is open science? So research data management, within my old job, DCC, we defined it as the active management and appraisal of data over the life cycle of scholarly interest. So as researchers, you're creating lots of data. Obviously, you have to document it. You have to know, name your files properly. You have to know what that data is, have to structure and organize it so you can find it and store it in an appropriate place so that you and any collaborators have the right levels of access. But there's also this concept of appraisal, selection, because not all of your data maybe needs to be kept long-term. You obviously need to evidence your research results. Some things will be valuable data that you want to share with others, but maybe some things, you know, it's like versions of the data that you don't need to keep. So it's about data management's about organizing and structuring your content and deciding what to share. And it's really just part of good research practice. You're going to be doing data management already. And the key thing is just making sure you've got the support and the knowledge that you need. And that's where the libraries and other stakeholders really come in. So things involved in data management, often data management planning. So at the outset, think about what you're going to create, what has long-term value, how you're going to document that data and version it, where things should be stored, because that will have implications on making sure it's properly backed up and that people have the relevant access. And it's also about you know, the sharing in the long term, preparing your data for deposit, thinking about your publishing, what data needs to be shared with alongside a publication to evidence the results. And when we're thinking about sharing, it also brings in concepts like licensing. If you make your data available, you need to think about what license to use, who it should be open to, how people can reuse it, and also citation so that you get credit for your data. So these are kind of the activities involved in data management. There's lots of reasons to manage and share data. There's obviously direct benefits for you as researchers. It makes your life easier. If your content's well structured and organized, you're not struggling to find the right version of things. You can reuse your data yourself later on. And there's also big benefits in terms of advancing your career, because if you're publishing your data, you can get a lot of recognition for that. Obviously, research integrity plays into this too. We have had cases where, you know, people have faked data or results can't be validated, and you want to avoid accusations of fraud or bad science. So it matters to manage your data well and to allow your results to be validated. And there are policies, you know, either at institutional level, codes of good practice, or policies from funders in this area. And I think one of the key things is when you're sharing data, there's benefits for you in doing that, to get credit for your work, to get greater visibility of your research, new potential collaborators, and greater impact. And it also helps your community. You know, when people share data, it helps to speed up science and innovation and advance your field as well. When we think about open science, really what we're talking about here is doing all of your work in an open way. So it's science carried out and communicated in a manner that allows others to contribute to it. I think when we think about open science, we're often thinking about the publishing at the end, making content available, either open access, open data, but really we should be working in an open way. That's what open science is about, so that others can contribute to your work and collaborate with you. And as we saw, there's lots of things involved in open science. It's about the data, it's about your source code, it's about having open methodologies and even peer review processes for publications. There's open peer review, you know, making sure that reviewers are not anonymous, that you can do things in an open way. And it also touches on things like open educational resources, so the MOOCs that somebody had flagged. I think you probably know a lot about open access publications already, but obviously when you publish, you can make your publications open, and there's two main ways to do that. We call them the gold and the green route. The gold route is kind of led by publishers. You pay article processing charges and they will make your content openly available. But there's also a free route to open access, which is self-archiving your publication in a repository. Publishers will have policies about when you can release the version or what version you can release, because they don't want their version, you know, with all the publishers kind of formatting released in many cases, or they might have an embargo. But there's a tool that you can use called Sherpa Romeo, which lists all the different publishers and the journals. So you can search for, you know, Nature or wherever you're publishing, and you can see what they allow in terms of open access. Open data, which is much more the field that I work in, is about making your data freely available so that it can be modified and shared by others. And there's kind of different levels of open data. If you make your data available in any format on the web, it is technically open data, but it might not be that reusable. So if you have, you know, like a Excel sheet, and you, in the publication, you release an image of that Excel sheet, that's very hard for somebody to reuse because they can't actually manipulate the data. So what you should be doing is making your data available in a reusable format, ideally non-proprietary format, so CSV instead of Excel, because somebody else might not have the same software package to open it. And you should, you know, kind of make your data as rich as possible. So linking between aspects of the data, using URIs to denote things, and kind of sharing the whole context of your research. So there's this concept from Tim Berners-Lee about the 5 stars of open data. So it's about making your data available in a useful way. As I mentioned, open science also covers the methods, and there are also different tools that can help to document and share your workflows. So things like My Experiment and Taverna, so that you can share your code and tools, so that if somebody wants to reproduce your research, they don't just have the data, they have the way that you created that, did your analysis, and they can replicate results. So open science is really about openness at every stage of your research. So being open about how you're conducting your research and the analysis. And it's really about trying to publish earlier, sharing not just the paper, but the data, the methods, the code, and supporting reproducibility overall. And there's, as I mentioned with the open data, there's degrees of openness. Not everything can be freely open to everybody, that it can be used for every purpose. It is legitimate at times to have either embargo periods, you know, so that you can publish and you can use your data first. It's fine to have an embargo, or restrict the content for certain uses. You might say that, you know, you're sharing your data, but you don't want commercial reuse, or there might be reasons because you're working with human subjects that data has to be anonymized or only used for particular purposes just to protect the participants. So it's kind of on a scale as well. We want to try and avoid things being completely closed. So the push from funders and others is to make things open, but you have to kind of do that in a managed way. To explain a little bit about FAIR, FAIR overlaps with open science and data management, but it doesn't mean exactly the same. FAIR is a set of principles to ensure that data are shared in a way that both humans and machines can enact and work with them. So FAIR stands for findable, accessible, interoperable, and reusable. So it's about, when you're making your content available, ensuring it can be discovered, it's properly described, ensuring it's accessible. Somebody, you know, can actually go and download that data. And the interoperability and reusability is really about the standards that you use, so that if there's 2 relevant data sets, somebody can bring those together because they know that this value in one data set, you know, matches with something that may be described in a different way in another data set. So this is the principles in full. You probably don't need to know all this detail, but findability is about making sure there's an identifier, a persistent identifier on the data so that it can be discovered. It's about making sure there's proper metadata, that things are indexed so that when it's in a repository, you know, it's discoverable and you can know what you're referring to. There's support around FAIR data, like this checklist that I've linked to, that just tries to explain the principles in an easier way for researchers so that you can see whether you're conforming with FAIR or what you maybe need to do to make your data more fair. And the key thing I'd say with all of these things, FAIR is nothing new. Research communities have already typically been practicing FAIR. You've been making content available, but it's just a kind of a way of explaining what you should be doing. And I think FAIR's got a lot of traction because it's quite a nice acronym and a meaningful explanation. So you'll now see FAIR mentioned in a lot of funders' policies, but it's not really anything substantively different to what you've been asked to do before. One thing I'd explain about open and FAIR is that they don't mean exactly the same. Funders probably refer to both, and they do overlap, the concepts overlap, but you can have data that's fair, but not open. So it's data kind of under restrictions. And you can have open data that's not really fair. So if you think about that scale I said of the 5 stars from Tim Berners-Lee, you can have open data that's not really reusable. So this is why FAIR is important as well, because that's really about the reusability of data. And both of these concepts are on a scale. in my view, these three concepts kind of overlap. I think the primary thing to really engage in is managing your data well, because that's your own interest. It makes sure you can reuse your data. But ideally, you would also be making your data fair and open. But the benefit really there is for others, because that's about the kind of public sharing. And I'll maybe not go into this in detail because it's kind of more for people kind of supporting in the field, but we do have papers that explain the different concepts and how they overlap. And what we recommended in this paper was that for people who are on the support side, using open and fair is quite a good way to engage researchers in data management, because I think data management is often overlooked. I think that might be one more slide on this. What I've found in the area that I work in is that a lot of data isn't managed well, or open or fair. I think a lot of researchers have content, on hard drives, and it's not necessarily like accessible even with collaborators. And I think it's difficult to manage your data well. It's quite a lot of work. And this is why it's important that the support services are there to help you. I think one of the reasons people struggle with data management is that it actually takes quite a lot of time and effort to make things, well documented and, described, and to actually make them openly available. There's quite a nice blog about the cost of open science, where a researcher talks about how much effort that was for him to prepare his data set, to prepare the code and share it. So it's quite a big investment of time. And I think when we're working in support services, we have to recognize this as additional work for researchers. And also the recognition and rewards aren't always there yet. So it can be quite difficult for researchers to see the value. So this is something we need to, at a kind of policy level, try and change. And also communities are at different stages of maturity. Some research communities are very well organized, like astronomy and physics. They have domain standards, and there's a general practice about making content available because it's kind of built into the structures. In other areas, there's not the same practice. So it needs to try and, we need to try and support at a global level to help those communities organize themselves and develop their standards. So for support services, I'd kind of be mindful when you're working with researchers about the fact that this is extra work and it's not always that easy. And it's maybe not already part of the research culture to do this. So that's a quick introduction to the concepts. I'm going to come back to the Menti now to move on to the next section. But if anyone has questions, there's nothing in the chat just now. But if you have questions, by all means, speak out as I transfer. But hopefully it kind of explained the background a little bit to you there. So I'll just come back to the Menti. What we're going to move on to next, we've covered the what's involved in data management, is EOSC, which is a European initiative really trying to support open science. I see most of you haven't heard of EOSC, so I'll try and explain EOSC in a bit more detail. And I've got a question to see if those who have heard of EOSC, if you know what EOSC is. And in some senses, all of these answers are correct. So all of the above. EOSC is about kind of having services at the European level to help make things open. It's an EC program that's trying to bring together all of the research infrastructure across Europe so that researchers have access to services that are relevant to engage in open science. Okay, so I'll go in and explain a bit about what EOSC is. Okay, so EOSC is a big initiative that's really been funded by the European Commission. It's a collaboration between the Commission and all the member states in Europe to make open science the new normal. And there's different kind of political bodies involved in EOSC. There was an association set up as a legal entity to try and govern and oversee the initiative. And we work with the European Commission and also the member states through a steering board. And it's been a big investment in infrastructure. It's 350 million that's been invested in the initial development, and there's a lot more being invested in the coming years through different projects. And EOSC is trying to build what we call the web of fair data and services. It's about taking all the research infrastructure in different countries, whether that's, you know, repositories or other services, and federating them so that it's easier. We have like an environment in which researchers can share their data, and that data can be brought together with relevant services to perform their analysis. And I guess one of the ideals or ethics underlying EOSC is that countries are at different stages of maturity, and what we want is that all European researchers have equal access to the support and services that are available. So it's about trying to make a European landscape and platform so that you all have support. And the EOSC is about enabling multidisciplinary discovery and reuse. Researchers may be going to a domain repository, you know, in the social sciences, but there might be relevant health data that they also want to access. And within EOSC, what we're trying to do is federate that infrastructure so that when you go to a service, you can also access content from other services as well. So it's about bringing together, not physically bringing together content in one repository, but linking between them. And the concepts that are involved in EOSC, FAIR is quite a central concept. It's in the European Commission's policy. And FAIR is really what I'd call the glue that helps us connect the data and services. So what I said about FAIR, it's a lot about the standards. It's about making sure things are well described to international standards. And that enables us to then connect data from different disciplinary backgrounds. The way EOSC is being built, there's lots of projects. So EOSC can be quite a hard landscape to navigate, but there's projects working at different levels. So sometimes they're working within a different geographic space. So EOSC Nordic is a collaboration between all the Nordic countries to share the infrastructure there. There's also projects that are working in certain disciplines. So EOSC Life is a collaboration between all the different life sciences. Or SHOC is social science and humanities. And then there's also projects that are working on specific aspects of the problem, like FAIR's FAIR or now FAIR Impact, really trying to help define all the standards and the protocols that are needed to implement FAIR in the context of EOSC. So when you're looking at EOSC, there's often lots of different activities going on, and you may see things under different acronyms or names because it's projects. I think one of the key things, somebody had asked about where you can find open data. There is an EOSC portal, which is kind of like the main interface to access EOSC. And this EOSC portal harvests information from lots of different repositories. So you can search here to find relevant services, relevant data. And this is pulling content from national repositories or subject-specific repositories. And you can see here, I don't know if you see my cursor on the screen, possibly not. You can search for publications, data, software, different services like lab notebook services or storage services. And there's also a training catalog. So if you're wanting open educational resources or training materials, they're also available. So I think this is one of the key places to look for content or to access EOSC. There's also the EOSC Association, which is a membership organization that tries to represent all the communities in different countries that are engaged in open science. So EOSC Association is really the governance, it's not the implementation. EOSC Association isn't running the projects or delivering the services, but we work with all of those projects that the European Commission has funded that are doing that implementation. And in Israel, the Israel Science Foundation is a member of EOSC. So I think that's a good way for you to share any needs you have and to feed those into the association. Within the association, we've been working with different countries to run what we call tripartite events. And this is where we bring together, you know, the political people in the country, the ministry, or the different research funders, together with universities and with research communities. And it's really to try and understand well, where you're at with EOSC. It could be that we're helping you define policies. It could be that we're doing practical things, running workshops with you. Those tripartite events differ based on what's needed in each country. And there's a number that have been run. I don't think we've run anything in Israel, but that's potentially something that could be done if there's interest to bring the community together around EOSC. And in terms of the tripartite events we've run so far, there's been quite a lot of outreach on EOSC. We've worked in 16 different countries so far and reached over 1,200 participants. So EOSC is kind of in the building phases at the moment. There's the governance aspect where the association, the board that I'm on, is trying to help steer all of the work to build the EOSC platform. And then we're working with the individual countries to try and help promote the local needs and make sure researchers have access to the relevant content and services they need. So that's an overview to what EOSC is, which is kind of, I guess, the European implementation of open science. Again, actually, I see some things in the chat. Let me have a quick look here. EOSC equals global brain. I guess I might be misunderstanding here, but EOSC is like trying to implement open science on the European level. But there's similar initiatives to EOSC in other countries. So there's the African Open Science Platform, there's the Australian Research Data Commons, and they're like EOSC, but in Australia and Africa. And there's also like a global forum through the Research Data Alliance where these different initiatives come together so that the standards we use in Europe can interact with the standards that the Australians are implementing, and that we can try and have more of a global approach. I certainly will share the PowerPoint. I can put it on SlideShare, but you can also put it on whatever website or event program you have. And there's a question I can't read, I'm afraid, but if anyone wants to speak out, by all means do, and I'll pick up on that as well.
They're asking whether the presentation will be available.
Okay, so yes is the answer. It's also openly licensed, so if you want to reuse any of the content in either presentations you do locally or anything else, by all means do. Obviously, you can translate it into your own language, so it's easier for people to understand. Okay, so I'm going to come back to the Menti and move on to the kind of final section. Let me try and come to the right screen so I can come out of the slides. The final section is really about the practice for you. How do you, on a basic level, engage in open science? So the first question here is asking to what extent you practice open science. And it's really heartening to see that most of you hope to or try to practice open science. People are publishing open access and sharing data. It's actually surprising that more people are sharing data than publishing open access, because publishing open access is often the easier starting point. And good that some people are, sharing code. It's interesting using other people's paper and data. That usually is higher than practicing yourself. I think we see the benefit that we use other people's content, but it's a lot of work to share our own. So I think that's quite common, that you're on the reuser side rather than on the sharing side. But hopefully we can transition that more people see the value of sharing their content themselves. And then the other, what stops you from being open? I think high APCs is definitely an issue in terms of open access. Lots of publishers charge thousands. So the one thing I'd stress about open access is that you don't actually have to pay the APC. You can make a version of your publication openly available through the green open access route. And most people want to pay the APC because they want, to have their content available through the publisher, but there are other free routes. the expectation to publish in Q1 journals, I guess that's like high impact journals. That can be a barrier. And then the policies can also be a blocker. I think often there's a lot of expectations on you and not enough support. So that can also be a barrier. Okay, so that's the end of the Menti. Thank you so much for all contributing to that, because it helps me understand your needs. What I'll do, I'll come to the kind of closing section of the presentation now about practicing open science. And I've kind of got two subsections here, one aimed at researchers and then one also at support staff. So the first one, how to practice open science. So as researchers, if you're wanting to make your data openly available, the first step is to choose what data. I mentioned at the start of the talk, this notion of appraisal and selection. You won't want to make all of your data openly available. A, because it's a lot of work to make your data open, but also not everything has value to others. You maybe only want to make, a subset of your data openly available. So the first thing is to choose what to make open. And you may need to revisit this step later on, because you might think, I want to make this open, and then you realize you actually don't have the permissions to do that. Maybe you're reusing somebody else's data and you only have permission to use it for your own purposes, not to make it open. So, you have to think about what's applicable and whether you can make it open. Once you've decided what to make openly available, it's key to put a license on your data. And that's so that others know how they can reuse your data. Can they, do they just need to give you credit? So CC BY is just to acknowledge the author of the data. There's also other licenses like non-commercial and no derivatives. You might say somebody can use your data, but they can't create a new data set from that. So they can't mix up your data with somebody else's and create a new output. And then you make your data available. So you need to think about what format your data's in. Ideally, it's an open format so that others can reuse it easily. And I think the key thing here is using repositories. So if you make your content available in a repository, that makes it much more accessible, because that repository is providing the access and making sure it's indexed. If you just whack your data up on your own personal website, it's not going to be as discoverable. So this is kind of the final thing. Make sure it's registered in catalogs, and depositing in repositories enables that.
Sarah, if I may add something, we don't have in Israel almost no repository. So when we need a repository, we either use, for data especially, it should be Zenodo.
Yes.
Or a subject repository.
Yeah.
For example, if you use data in physics, there are repositories which are...
I'm sure I have a slide on this, on repositories. There's a catalog of repositories called Re3 Data, and I'm pretty sure I'm going to come on to that, but I'll flag that if it's not in my slides. So as I mentioned, license your data openly. There's guides on how to license data and what these different concepts like NC, non-commercial, mean. In terms of the European Commission's guidelines, they recommend 2 licenses: CC0, which is committing your data to the public domain, so there's no restrictions on reuse, or CC BY, which is just to say you need to acknowledge me as the author of the data so that you get citations and credit. And there are tools. So there's a really nice licensing tool from UDAT where it asks you a series of questions, and based on those answers that you give, it tells you what licenses are applicable. So CC BY, CC0. It also covers software, because there's a whole series of different licenses for software like GNU, GPL, and so forth. So if you're sharing your code, this will also recommend licenses for code. And yes, this deposit data in a repository, as was flagged by Simcha, you don't have a repository in Israel, you probably don't have an institutional repository, but there are lots of repositories out there. Re3 Data is a repository, like a catalog of repositories. You probably can't see very well on the screen grab, but you can search by subject. You can say, I'm working in, I don't know, humanities, and it will tell you all the humanities repositories. You can also search by content type. You can, search by country. Zenodo is a really good catch-all repository. It's one that's supported by the European Commission, but there are also subject repositories. And we did a little video actually in a training project called Foster Open Science that explains how to find relevant content in Re3 data. So by all means, look at that too. In terms of selecting a repository, sometimes your funder or your community may suggest a place to deposit. So as was mentioned, some communities like physics will have repositories. So it's often better to use a domain repository if there is one in your field. You can also look at things like whether the repository provides like details about how to cite your data. That's also good. If the record of your data has a here's how to cite it, that's good for you because it helps you get impact and credit. A lot of repositories are assigning persistent identifiers, and that's also good. So if you have a repository that does that, it helps make your data more fair and more discoverable. And there's also a concept, repositories can get certifications. So we have this notion of a trustworthy digital repository. And that's a repository that's gone through a lot of hurdles to show that it's really robust, that it has long-term plans, it's going to sustain your data in the long term. So if you have a choice between a repository that's got a certification or not, you probably better to go for the certified one. Another thing that's key for researchers is using relevant standards to document your data. And again, there are catalogs that point you to metadata standards in your field. So there's one that's provided by the Research Data Alliance. There's another resource called Fair Sharing. And within these catalogs, you can say, I'm working in, social sciences. What are the relevant standards? Things like DDI. And it will point you to the standard. It will tell you about tools that you can use to help document your data. And then it's also important to choose appropriate file formats. So when I mentioned earlier about this scales of open data and the level of fairness, if you make your data available in open standards, it's much more reusable by others. And this is a table that comes from a social science repository that explains, if you're sharing text, it's better not to share it in Word. I know most people will because everyone's using Word, but if you make it available in plain text, it's more reusable. The same with spreadsheets. If you make it available as CSV rather than an Excel file, it's more reusable by others. And the same applies with like images, formats like TIFF. Are much more kind of reusable formats because they're open standards. There's also a really nice guide that the UK Data Archive shares that talks you through how to manage and share your data. And it's very practical. I think it's about 30 pages, but it helps explain these concepts of how to format, how to document your data. It explains about licensing and copyright and consent and ethics. So that is probably a useful starting point if you're wanting some advice on sharing your data. There's also training resources that can be helpful for you as a researcher. So Mantra is an online course that's freely available, and it goes through little tutorials on things like how to prepare your data for deposit, how to share your data. It has different data handling tutorials. So this is something I'd recommend looking at if you actually want some kind of training or education on more detail of how to manage and share your data. And then just to come to a close, the other aspect is for kind of librarians and support staff on how to support researchers. There were some questions at the start about how to set up services. Again, there's lots of materials to help you here. At my old job at DCC, we developed guidelines on how to set up research data management services and the things that you need to cover at an institutional level, like support for data management planning, kind of storage, repository services, and how you kind of like, establish a business plan so that your institution invests in this area. So there's a lot of useful resources there. What we found when we worked in UK universities was that libraries were typically leading on this. We did a series of engagements with different unis, and it was often the library leading, but there are other stakeholders who are important in your university. Obviously IT services, but also the research office normally plays a role because that's who researchers are working with when they're applying for grants. And I think in terms of setting up services at the institution, it's really important to have academic champions because, you know, this is for researchers and you need to make sure the services that you put in place, you know, work for researchers and meet their kind of practices. So I think it's really important to have academics involved as well. The ways libraries have typically been engaging in data management, they're often defining the institutional strategy and putting policies in place. Libraries are often that kind of front-face human support, so they're often delivering training courses or helping researchers to write DMPs or advising on things like data sharing and citation. And you can look at other libraries. I mentioned the Netherlands is really far advanced here. You can see what other universities have done and try and use that as a model, and also learn from what they've done. So like the mantra resource I showed earlier, the training course, that's an open educational resource. So you can take that content and make it available in your own university as well. There are kind of emerging job profiles in this area. So this notion of data stewards or data scientists or research software engineers. And I think as you kind of, you know, build your practice in Israel as well, you may see some of these roles coming out within the institutions. There are lots of good examples from other countries where you can see how people have set up data steward programs and made sure that they've got support at the local level, or there's training courses like the Co-Data Summer School to try and help people learn the relevant skills to be a data scientist. So that, again, there's some links here that you can follow up if you want to know more, and I'm also happy to answer questions on these areas. As I mentioned, there's the mantra resource that I pointed to for researchers. There's also toolkits to help librarians and other support staff upskill so that they can help with open science and open access. And I think this is a really nice resource, this DIY training kit for librarians. It's really about coming together as a group of librarians and as a peer group, supporting each other to kind of move into this new area of work. It uses the mantra resources, but it's a kind of reworked version of that for support staff. And it has lots of exercises so you can try and think about what support researchers may need and how you can offer that support. And it's been used by a lot of different universities to try and upskill within the library community. There are also MOOCs, online training courses aimed at librarians and support staff to help you establish research data management services. So there's a MOOC that we put together in DCC with Research Data Netherlands. I don't know when it will be running again. It's on FutureLearn. It normally runs once or twice a year. But by all means, look at that and sign up for the next running of the MOOC, because that's also a way that you can learn together with like global peers. So libraries in other countries that are also trying to, you know, develop services in this area. And again, on that MOOC, there's lots of discussion for and exercises to really help you learn how to advance work at your own institution. I think that was my last slide. So just about on time. We've got a little bit of time for questions if you have them. But hopefully what I've done is explained a bit about the concepts, but also some practical links to how to make your data open or how to have relevant support services in place. So thank you very much, all of you, for listening. I'll stop the screen share so we can actually see each other. And if you have any questions, I'm very happy to take those.
So there is a question in the chat from Elena. Is EOSC available for data depositing to Israeli researchers, or just for the ones that get a grant from the European Union?
No, so EOSC is a federation of services. So EOSC is bringing together all of these different research data repositories from different disciplines, from different countries. So you're not depositing with EOSC per se. There's not a place that you go to the EOSC portal and you deposit. You deposit in one of the repositories that's relevant to you. So I would suggest you look at Re3 data, you find a relevant repository, and then that content will be pulled into EOSC. Sometimes repositories may have restrictions. They may only accept data from their country, but lots of repositories accept data from anybody, any research community. As was mentioned, Zenodo, I'm going to put, I'll maybe put the name in the chat. Zenodo is a kind of catch-all repository. It's run by OpenAIRE and it's supported financially by the European Commission. So I would say Zenodo is your first place to look for deposit, but there may be other repositories that are more relevant based on the subject area you're working in. But yeah, lots of these repositories are, you know, openly available.
If I may ask about, which is connected to this question, is the OpenAIRE portal has a lot of data and publication, which is also aggregated. Does EOSC have an added value to OpenAIRE or?
Yeah, so actually it's the software of OpenAIRE that's used within EOSC. So it's, I guess it's a parallel service, but with a larger scope. So it's very similar to the OpenAIRE portal, but it's within EOSC, it's a broader scope.
I have a question. When you come to implement an open science policy, what are the main challenges that you encounter during such process? Yeah,
so I think the easy thing is writing the policy. The harder thing is implementing. So there are lots of policies you can reuse or take lessons from to define the policy. But the difficult thing is getting the relevant buy-in to implement it. Because it's very easy to say, you know, researchers have to manage their data. But if you don't enable that with the services, then, you know, how do they manage their data? So I would use the policy as a way to kind of influence management within the university to invest, you know, say you've signed up to this policy, so now we need the services. And I guess the two key implementation challenges, first off, is getting the level of support and investment to make it reality, to actually implement the policy. But then it's also the engagement, because none of us like to be told what to do. You know, we see policies, we have all of the, normally all these websites, we go and we tick the terms and conditions, nobody reads them. I think our way of approaching policies is kind of file it in a drawer, not really look at it. So trying to engage researchers on why it's important is probably the other key implementation challenge, and focusing on the benefits for researchers. So trying to have the services in place to alleviate it and to make it easy to follow the policy, but also working on the advocacy and taking it a step at a time, you know, be realistic about what can be implemented, because you know, managing data, making it open is a culture change for researchers in many cases. So that's probably the implementation challenge.
Isn't investment of money a big issue?
Yeah. So as I mentioned, in the Netherlands, we've been very fortunate because the research funders supported a lot, but it's not always easy to make the case and get investment. There's different ways you can drive it. I think you have to, first off, you have to understand who is the decision maker and the person who's really going to be influential in your university. In some UK universities, what drove the argument was, well, look, the university down the road's doing this. If we don't do it, you know, we're falling behind. In other cases, there was like a PVC who was in an area where it's common practice to manage data. So using that person who says, this is what everybody does, help to drive the change. So sometimes it's having an academic champion who can really say, this is just what researchers need. And they can be very influential on getting the university to invest. Sometimes it's, you know, working with research funders at the national level to lobby for change with the ministry, and, you know, and that's a way you can push things down into the uni. So I think the key thing is just talking in your context, understanding who are the influential people who will help you make that change, and then also what are their interests, because if you find something that connects with them, then they will push the argument for you.
You talked
there is another question in the
about GPT.
So
I think it's a very interesting
day.
Yeah, I think it's a very interesting tool. It's fascinating, the results you can get, and incredibly accurate, you know, like the way it's pulling lots of different documents and information. You actually get quite sensible things from chat GPT. Like my background's are humanities, so I have a concern about how tools like that can be misused, you know, like so I think yes, it's good, but often technology advances quicker than the policies and the kind of like the safety aspects we put in place, you know. So if we think about something like Facebook, you know, like everybody's sharing content and personal information that then is being, you know, it's a business opportunity. So as soon as something about your interests, like what book you've bought or something you've talked about with friends, you're then marketed, you know, and people didn't expect their content to be reused in that way. And I think similar things can happen with new tools and innovations like chat GPT. You know, it could have some negative influences if there aren't proper kind of safeguards in place. And we're often slower to put those safeguards in place because technology and innovation happens very quickly and things get jumped on because they're really useful tools. So I think it's good, but use it with caution. Yeah.
I have another question. You talked about the data stewards. What is the profile of the people who are engaged in that? What are they? Librarian, scientists?
Yeah, mostly data stewards have a scientific background. So often it's people who've done research, done a PhD, they have a knowledge of a subject area. And then what they do is they work, they kind of they're a bridge between the support, the library side, the information management side, and the research practice. So usually they have a background in the research because they need that to understand the researchers and what they need. But they bring the information management expertise too. Sometimes it is librarians who, you know, upskill and can work as a data steward. It doesn't, you don't have to have come from the research side. But I think one of the really critical things as data stewards, they're usually focused on a subject area. And I think that's quite a hard thing to learn if you don't have that subject background. So I would say often it's somebody who's come more from the research side, and then is performing a kind of research support role.
So university needs quite a few data stewards.
Yeah, I mean, it's difficult because obviously it's a big investment, but usually there's multiple data stewards. So people might try and have, you know, like 3, you know, in like the main faculties. It depends how your uni's structured. It might be 1 per faculty, so each kind of key subject or big block of subject areas. In some places, like in TU Delft in the Netherlands, I think they've got like 20 data stewards. They have them, you know, like really quite focused on different subject areas. But that's like the dream, you know. I think it's very hard to get to that level of investment. You could, I mean, even if you don't have like disciplinary data stewards, it's good to have somebody who can try and help bridge between the research world and, you know, and the kind of support side. So you could have, a lot of people just have like an RDM support officer who's trying to cover all subject areas, but it's difficult if your background's not physics. It's not always easy to understand, you know, the researchers' work and what they need.
Okay, thank you.
Thank you.
Any other questions?
No, so I think we covered everything.
Excellent.
Thank you so much, Sarah, for a
You're
fascinating presentation. I learned a lot.
Me too.
I thought that I know quite a lot about the data management, but I learned a lot. So thank you very much for joining us.
You're welcome. And if anyone has follow-up, I'm conscious there's a lot of content and I went through it very quickly. By all means, like reach out to me via email if you want to know any more, and you're welcome to reuse the content, follow up the links. And yeah, good luck and happy open access week.
Thank you.
Thank you.
Thank you. Goodbye.
Thank you all. רגע. יש כאלה שעוד לא עזבו. יהודית הלכה?
לא יודעת.
יהודית, את פה? לא, היא הלכה, למה היא הלכה?
אני אצלצל אליה, תוציא את האחרים.
רגע, אני צריכה לעשות.